Okay, hello everybody. So I'm going to go through a contingency table problem where I'm going to be doing a logistic regression. I'm going to start by just creating some kind of dummy data, and we'll talk through what we're going to do with this data. So first off, we'll just come up with some variables that I'm going to measure. Let's say we sampled a whole bunch of people, and we want to predict. Let's say we want to predict some categorical variable, like a yes or no variable, based on something else about them. Does the person dance? And they're not a dancer, or they are a dancer. They either dance or they not. And we have, let's say, three. Let's have our other variable just be some. It's just any old dummy variable. Let's say hair color. I'm going to put 3 levels. The thing is, though, that since I'm going to be doing a numerical analysis, like I'm going to be using logistic regression, I want to encode this with numbers. So let's just say I have 3 hair colors, and I could actually give them any number, but the logistic regression at the moment requires all the data to be numerical. And so rather than putting, say, like brown, black, and red or blonde, rather than doing that, I'm going to just use numbers 0, 1, and 2. Okay, and I'm going to just fill in some numbers. I'm going to try to just generate some random numbers, as random as I can in my own mind. Let's say Okay, so this stuff is totally made up and totally ridiculous. I'm not actually going to do any analysis on the contingency table page. What I'm going to do is I'm going to convert this to a data table. Like data columns. So click on data, and you'll see what we have is, for the dance variable, we have rows of data. So many people said 0, like they don't dance and they have hair color 0. They have hair color 1, hair color 2, and so forth, so forth, so forth, so forth, so forth. Okay, so this is all my data. I'm going to just copy all this data, and I'm going to open up a new tab, and I'm going to open up the multiple regression tab. In multiple regression now, let's copy in our data, and I want to, since I only have 2 variables, I have a response variable, which is dance, and I have my predictor, which is hair color, but I don't have a 3rd variable. I'm going to reduce my independent variables to 1 independent variable. So I'm going to click calculate now, because at the moment you have to just jumpstart the calculations by doing that. But let's go down to regression options. What I want to do is so I've already specified response variable is dance. That's correct. But I don't want to do a linear regression. I want to do a logistic regression. And the other thing is hair color. I'm going to classify it as a dummy variable. When you do that, it is going to, rather than have interpreting the value 0, 1, and 2 as numbers and making a regression where we take that value times its coefficient, what we're going to do is, for dummy variables, we always have 1 fewer dummy variable than the number of outcomes for that variable. So there's 0, 1, and 2. Really, the variables 1 and 2, or the values 1 and 2, would be considered. Let me put it like this: the first value 0 would be like a baseline, and if somebody had hair color 1, what we're going to do is consider like the baseline plus some difference, and that's going to give us the kind of the situation where they have hair color 1, and the baseline plus the value, the coefficient for when they, the difference kind of coefficient for when they have hair color 2, and that's going to be that's going to kind of categorize people as like having hair color 2. That's all happening under the hood. You don't see any of this happening. But anyway, that's why we have hair color D1 and hair color D2. The D stands for dummy, and the 1 refers back to the value of hair color back in the data column. So value 1 and value 2 are dummy variables, and 0 is going to be just built into the baseline, into like the essentially the intercept term. But anyway, that's that. I'm going to go down to regression options. And so what we have here is my regression statistics. I have the log odds of dancing is this intercept term plus this coefficient times dummy 1 plus this other coefficient times dummy 2. So what that means is if a person has hair color 0, what I would do is I would put, to calculate their log odds, I would just it would just be 1.335 because I'd be plugging a 0 in for D1 and a 0 in for D2. If a person has hair color 1, then I would plug in a 1 for hair color D1 and a 0 for hair color D2. So their log odds would be 1.335 plus 0.418. And if a person had a hair color 2, then I would plug in a 0 for hair color D1 and a 1 for hair color D2, and then their log odds would be 1.335 minus 2.316. That's how you calculate log odds using these dummy variables. I mean, this is all made up stuff, so I'm not really too concerned with all of the other regression output. We could look at like the scatter plot to just see how good of a prediction. I mean, it looks like I'm predicting more often than not. I would be predicting correctly using this regression, even though it's all just made up. Look at the scatter plot. Unfortunately, it's really hard to see here anything meaningful because all the dots are on top of each other, right? What we've got here is this logistic curve is actually not going to be too helpful for us. So actually, maybe I'm not, but the idea would be you have the plots on this. The vertical variable is dance, whether they dance yes, 1, or no, 0. And then the horizontal is the predicted log odds. So the predicted log odds range from -1, then there's 1.3-ish, and 1.8. This corresponds at 1.2 or 1.3, that's hair color 0. 1.8 roughly is hair color 1, and then -1 is like hair color 2. And so what we have is this dotted line showing where the probability, so the probability is this curve, this red curve, the probability curve. And when the probability is greater than 0.5, we would predict yes, and when it's lower than 0.5, we predict no. So again, you can't really see, but for these dots, there's a lot of them on top of each other. The idea would be you would want to have, on the right-hand side, most of the dots would be up in the top of the chart, and on the left-hand side, most of the dots would be on the bottom of the chart. That would be an accurate kind of classifier. But if you don't have that case, then you have a lot of misclassification. So in this case, all of the dots on the lower right and the upper left are misclassified by this logistic model. So anyway, that's how you would convert contingency table data into a logistic model for predictions. Now you can actually do this straight off with just, you can calculate the odds directly and calculate the log odds, and you don't have to use logistic regression in this way. You can actually calculate these coefficients directly. So let's talk about how you do that in the contingency table. So for each of these categories, you have the so for hair color 0, you want to calculate what are the odds that somebody has that somebody who has hair color 0 dances. That's what we're interested in. So what you do is you say, okay, the probability that you just take the number of them that dance, 95, because the odds are going to be the number of people who do divided by the number of people who don't. 95 divided by 25, 3.8. And then you take a logarithm of that, natural log. Then I get 1.335. If you go back to the logistic regression, that 1.335, that's the log odds for somebody who has hair color D0. Now going back, if somebody has hair color D1, you can take the 75 divided by the 13 and take a logarithm, a natural log, ln, of that number. I get 1.7525. But remember, when in the logistic model, this coefficient for someone with hair color 1 is going to be the sum of the baseline coefficient, like the intercept, plus the difference. So what I need to do to find this coefficient, I need to subtract from that the number that I just got, which was 1.335. That gives me 0.4175, so rounds up to 0.418. And if you go back, you'll see 0.418 is the coefficient for hair color D1. So if someone has hair color 1, then I would add those two numbers, and then I'd recover the point. I'd recover the log odds, 75 divided by 13, natural log of that. It would get back to 1.75. Finally, for hair color 2, you take 24 divided by 64, take the natural log of that, and I'm going to subtract 1.335 from that again to get the coefficient for someone with hair color 2, negative 2.316, rounding up, negative 2.316. And again, go down here, negative 2.316. It's right there, the coefficient for someone with hair color 2. So that is how you can get those coefficients without using, without going into calculating it this way, because in the background, the calculations for the logistic model is a lot more complicated than that, because it doesn't really differentiate whether it's a dummy variable, if there's only a dummy variable, or if there is some other non-dummy variables. It'll just calculate it using a certain method, but it'll arrive at the same coefficients. Anyway, that's how you can go from a contingency table to a logistic model for prediction. I hope that makes sense, and I hope you do well. All right, bye-bye.